Alright, let's see how we could implement this function countBlocks. It takes this integer levels as input, which is the number of levels the pyramid is made up of, and returns an integer which is equal to the number of blocks it needs. The first thing we need to do is declare and initialize this total variable here. This will keep track of the number of blocks it needs to build the entire pyramid by adding every level one by one. Then we start a loop that counts from 1 to the number of levels in this pyramid, and the increment is just I++. Inside the loop, and for each level, we need to calculate the number of blocks in that level, which is equal to I times I, because I changes from 1, 2, 3, all the way until the maximum number of levels. Once we calculate that number of blocks needed for that level, we just add it to our total variable, and update total to be equal to the sum. Finally, when the loop ends, we just return the variable total, because it would have the total number of blocks for all the levels in the pyramid. Let's test it out for a 3-level pyramid, which means our input variable levels here is going to be 3. Total is initialized to 0, and our loop goes from 1 to levels, which happens to be 3. Now let's keep track of every variable we have as we go through the loop. I starts by 1, and then we check this condition if I is less than or equal to levels, which is basically if I is less than or equal to 3, and that is true because I is still 1. So we calculate the number of blocks in that particular level over here, which is I times I, and then we add the result of I times I to total, which started as 0, so makes total equal to 1. We reach the end of the first loop, so we go back up, add 1 to I, making it equal to 2, and then check the condition again, is I less than or equal to 3, and it's still 2, so that's true. So we calculate I times I, which is 2 times 2, happens to be 4, and add that to total. Total was already 1, so we add that, making it 5. We reach the end of this loop again, so we go back up, we add 1 to I, making it 3. We do this check again, is 3 less than or equal to 3? Yes, it is, because it is equal to 3, so that's true. So we step inside again and calculate I times I, making it 9, which is 3 times 3. Add that to total, which was 5, so that's 9 plus 5 equals 14. And total gets updated to 14. So we reach the end of this loop, go back up, add 1 more to I, and then we do this condition again. Is 4 less than or equal to 3? Nope, it's not anymore, so we do not step into that loop anymore, and we just skip down here to return total. So the value of total at that point is 14, which is the output of this function. That is if the input is 3. Brilliant! You could also try to trace it with larger input values and see if it works for that as well.